Hello, in this module we are going to see the explorations of R on Gehan test. It is one of the statistical tool used to compare survival curves. It is available in library called survival analysis, and we will see how the Gehan test applicable on that on sample data. As a sample data, we will consider here the ovarian cancer data. That data also available in library, R library called survival. The Kaplan-meier estimations procedure we will adopt here. Thereafter, we will see the log rank test to compare two arms, and later on we will see the Gehan's Wilcoxon test to compare the survival curves. Kaplan-meier estimate is one of the best option to be used to measure the fraction of subject living for a certain amount of time after treatment. In clinical trials or community trials, the effect of an intervention is assessed by measuring the number of subjects survived or saved after the intervention over a period of time. The time starting from the fixed point to the occurrence of event is called survival time. For example, death is called survival time, and the analysis of group of individuals is called survival analysis. This can be effected by subject under study that are uncooperative and refuse to remain in the study, or when some of the subject may not experience the event or death before the end of study, although they would have experienced or died if observation continued, or we lose touch with them after certain point of the study. We label this situation as censored observation. The Kaplan-meier estimate is the simplest way of computing the survival over time in spite of all these difficulty associated with subject or situations. The survival curves can be created assuming various situations. It involves computing of probabilities of occurrence of event at a certain point of time, multiplying these successive probability by their computed probability to the final estimate. This can be calculated for two groups or subject, and also their statistical difference in the survival analysis. In this, comparison of groups can be done by log rank test, and in this module we will check how to perform log rank test, and thereafter Gehan's test for again survival curves comparison we will test and check. In this module we will see the survival curve comparison using R. We will get the log rank text using R, and again Wilcoxon grand sum test using R. So, how to compare survival curves, and how to get estimate through log rank test, and how to get Gehan test for survival curves we will see here, and we will compare those graphs. This is the objective of this model. Now come to the data. This is the data, survival data taken from ovarian cancer study Edmondson 1979. It is a famous trial data. So, here the observation for first variable, if FU time is taken as a survival or censoring time of each patient from the study initiations to the follow up, how many of each patient, how many days they followed, it is considered as FU time, that is follow up time. The status of those patients are considered as FU status. At the end of the last follow up, what is their status, they died or alive,
if they are alive, it's taking as censored. If they died, it's considered as death. And the third variable is age, it's taken as in years. So from the study initiation or at the baseline measurement of their age of those patients is considered in years. Now fourth variable is resi .ds, it's called residual disease presence or not. It's a factor, prognostic factor, can be considered for and it's having negative impact. If the residual disease present, then it's having negative impact on those patients, whatever treatment given to them. And now the Rx is given as the treatment type of treatment. Here we are coding it as two groups. And last variable here in this study we are considered that ECOG.PS, that is performance score of those patients, and it is referred that the patients having less ECOG value having better performance, and that is value near to 1 is having good performance of those patients. Now we will go to the next slide for work on the survival card comparison, but whole thing will be covered by survivals are equal or not. So this is our hypothesis, and these survival curves between two groups, that is treatment groups denoted as a variable Rx, these are having equal survival or not, that we will test and we will infer from this data set. Now come to the how to call the data. We are going for reading the data, and the find first the time data is mentioned, that is follow up time is here we are considering 59, 115, 156, 421 days, and again the status of those patients given at 1010 like that, and treatment is given as is existing treatment or intervention treatment. So if it existing treatment is denoted as 1 and intervention treatment denoted as 2, and age of those patients are given as in year observed when they entered in the study. So like here the first patient's age was 72.33, second patient 74.49, and third patient was 66.46 years when he entered in the study. Like that, all patients exact age is considered here with 4 decimal places of their age value. Now the other variables like residual disease present or not is giving a receipt.ds assigned with 2 and 1. So it present is given as 1, if it absent is like given as we coded earlier, and ECOG performance score also given as 1 and 2. So if it is 1 it is better, and if it is 2 it is not better, like that. And the whole thing is assigned to data.frame. All the measurements, all the variables are assigned through data.frame functions to ovarian database. Now thereafter we will call the ovarian database, and the library is will be useful to carry this whole work is library survival. So now we are loading the survival library to perform the rest of work that we are presenting in this module. Now our next slide. Survival estimations at specified times. So that subfit functions available in the library called survival is useful to give the survival estimate at specified time point. Again this another function that is called capital S URV with time and status follows to Rx, that is statement of type, that is 1 and 2, will give us the survival estimates, where we have to assign data equals to ovarian with type equals to Kaplan-meier. See, last module we have mentioned type is equal to ln. Here we are mentioning type equals to Kaplan-meier. So the curve will plot it through Kaplan-meier estimation as a non-parametric approach. And once these whole functions are assigned as capital S dot capital K and M, and Now in next line we are assigning print of summary s dot k, that we are already assigned the function value as s dot km, and again we are putting the times equals to c of 5, 10, 30, 50, 100, 150, 200, 250 and 300. So it's your choice. If you want to get the estimated value for time period 5 days, 10 days, 30 days, 50 days, 100 days, 150 days, 200 days, 250 days and 300 days, you can put it like that. Otherwise, if you want to get the interval shorter like 50, 100, 200, 300, then in place of that 5, 10 whatever given here, you may put is only 50, 100, 200 and 300. So whatever the interval you want to see as a result, you may choose into the time frame to assigning the print of summary. Now see the results, how the results coming. The results you will give it as for Rx1 and Rx2 separately, and for Rx1 it will also give first column the time, and Rx2 also first column will give the time. And since we have assigned the time as 5, 10, 30, 50, 100, 150, 200, 250 and 300, so first column giving that interval, and corresponding that is giving how many patients were at risk in treatment 1 and treatment 2 separately. We can see that number of patients were at risk till 5 months, 5 days were 13, and it was same till 100 days, and after 100 days, 100 to 50 days, 150 days, one patient died, and then it reduced from 13 to 12, and thereafter again another patient died into interval 150 to 200 days, then again it reduced to 11, and like that again 250 days to 300 days one patient were died. So again number of risk patients in treatment 1 Rx1 is given as 9. So corresponding the survival probability also given as 1, and it was unchanged till 100 days. When it 100 days came, it reduced to 0.92, again 150 days is reduced to 0.84, again 0.76, and up to 300 days is reduced to 0.69. Corresponding that survival estimates is also gives the standard error value and lower confidence interval of that estimate, survival probability estimate, and upper confidence interval of survival probability estimate. If you go to the next down row, that is given for Rx2, it's giving again the time interval and number of patients at risk, number of patients where an event occurred, and survival and standard error also given into the next slide. So this is the basic survival estimations through Kaplan-meier, and now we will the separate estimates for treatment 1 and treatment 2. Now we will go for the numerical calculation for the survival curves. These curves are having different or not. To check that, we will go for next slides. Now this is the standard log rank test we will perform. To perform this standard log rank test, the function is called subdiff. The subdiff function is useful to perform the log rank test, where into that it's also compatible in the library called survival, where into that subdiff we will call the function surv and time and status, and data is equal to over here we will calling here, and here we are putting row equals to 1. If we put row equals to 1, it will by default it will calculate the log rank test. It is equivalent to the Mental-Hansen method, except the two methods differ a bit in how they deal with multiple deaths at exactly the same time points. The Mental-Hansen approach is useful but uses the same name with log rank, which is commonly used for both approaches. This method also called as Mental-Cox method. Now we will see the result observed given that subdiff, and here since the both arms are having equal number of patients, that is 13 in age, and expected value was given, and this observations and expected values was given. Now this is the output where we have considered rho equals to 0 for the data equals to ovarian, and served time and status with Rx is given. Now see the since both arms are having equal number of patients, that 13 in each, Rx equals to 1 13 and Rx equals to 2 13, and observed and expected are given as 7 and 5.23, and it's basically calculated the chi-square test, and as a chi-square test value we got it as a 1.1 value with 1 degree of freedom, and most interestingly the p value gives 0.303. that shows that there is not any significance difference between these two arms when we are getting we are calculating the log rank test. So served diff will give us the log rank test between two curves for arm 1 and arm 2, and if we put a served diff into the library survival, we'll get that result as we mentioned here, and in this sample data it shows that there is not any significance survival difference between these two groups. Now we will go for next code, that is to run the Gehan Wilcoxon test, and it's same like log rank test. In place of log rank test we had mentioned that rho equals to 1, but here we will put rho equals to in log rank test we had put rho equals to 0. In log rank it's same like standard log rank test. In log rank test we had put rho equals to 0, but here we are putting rho equals to 1, and we are performing the same data to just this is a simple thing in Gehan Wilcoxon test to perform. Now we will see the result, how the results coming. It gives that p value is coming with 0.19, where in log rank test we was having 0.33. so here p value reduced from 0.33 to 0.19. However, expected value also reduced 5 point something for treatment 1 to 4.12 for treatment 1, and again reduced to 5.23 for second treatment group. This is also done the chi-square test to find out the difference treatment difference, and chi-square test value shows with 1.7 with 1 degree of freedom. So here we can see that there is a slightly difference given by the p value to compare the two graphs. This method gives more, this Gehan Wilcoxon test gives more weight to date at early time points, which makes lots of sense, but the result can be misleading when a large fraction of patients are censored at early time points. In contrast, the log rank test gives equal weight to all time points. So that's the basic difference between log rank test and Gehan Wilcoxon test. The log rank test is more standard approach to compare the survival curve difference in comparison to Gehan test. It is more powerful also of the two tests if the assumption of proportionality hazard is true. If the proportional hazard means that the ratio of hazard functions, that is death per time, is same at all time points. One example of proportional hazard would be if the control died at twice the rate as treated group at all time points. This Gehan's Wilcoxon test does not require a consistent hazard ratio to apply, but does require that one group consistently have higher risks than the others. If the two survival curves cross at a time, then one group has a higher risk at earlier time points and the other groups has a higher risk at the late time points. This could just be a coincidence of random sampling, and the assumption of proportional hazard could still be valid, but the sample size is large. Neither the log rank or nor the Wilcoxon Gehan test, we are assume here, are helpful in that scenario. If in doubt, report the log rank test, choose the Gehan Wilcoxon test only if you have strong reason to do so. Now we will go for Gehan generalization of the Wilcoxon for 2 sample test. Again we are attaching the data over here, and the library called npsm is useful to perform that, and a simple command that is Gehan.test is useful to perform the generalization of the Wilcoxon 2 sample test, where into the parenthesis of Gehan.test we have to call time and status with Rx. This is the output results given as a statistics value as minus 1.37 with p value 0.16. So now in the same data set, initially the log rank test was given 0.33 p value. When we have only Gehan Wilcoxon test applied under the library of survival, it's giving us 0.19. Now when we are using the library called npsm, then it's giving the p value of 0.16. So the pattern of censoring into the data is need to be considered before applying any survival different test. What kind of censoring is there, right censoring, and what is the pattern of censoring in initial study period or later study period, that need to be considered before applying any survival test difference. But it is to be noted that log rank test and Gehan test can be performed in the same platform called library survival, where we have to mention row equals to 1 to perform the log rank test, and row equals to 0 for to perform the log rank test, and row equals to 1 to perform the Gehan test. But obviously log rank test is more adaptive approach and more generalized approach than Gehan test. Gehan test perform give weight to the data at early time points, which makes lots of sense, and also can also be misleading approach in some.
In this module, we have seen the application of R on survival curves. The Kaplan-meier estimate has considered first to build up the statistical inference. Thereafter, two curves are built on their survival estimations. Those two curves obtained from the two arms that was considered from the ovarian study data. Thereafter, log rank test was considered to make the comparison between two curves. Statistical inference on log rank test illustrated and on example data, and later on we have seen the application of Gehan test on statistical sample data and the statistical inference, how to conclude from that data have illustrated in this model.